For example, Linux is an operating system kernel that contains millions of lines of code, but it started out as a simple program Linus Torvalds used to explore the Intel 8386 chip. According to Larry Greenfield, one of Linus's earlier projects was a program that would switch between 4 capital A's and 4 capital B's. This later evolved to Linux. Later chapters will make more suggestions about debugging and other programming practices. Section 1.8, Formal and Natural Languages. Natural languages are the languages that people speak, such as English, Spanish, and French. They were not designed by people, although people try to impose some order on them. They evolved naturally. Formal languages are languages that are designed by people for specific applications. For example, the notation that mathematicians use is a formal language that is particularly good at denoting relationships among numbers and symbols. Chemists use a formal language to represent the chemical structure of molecules. And most importantly, programming languages are formal languages that have been designed to express computations. Formal languages tend to have strict rules about syntax. For example, 3 plus 3 equals 6 is a syntactically correct mathematical statement, but 3 equals plus $6 is not. H_2O is a syntactically correct chemical name, but _2 capital Z lowercase z is not. Syntax rules come in 2 flavors, pertaining to tokens and structure. Tokens are the basic elements of the language, such as words, numbers, and chemical elements. One of the problems with 3 equals plus $6 is that $sign is not a legal token in mathematics, at least as far as we know. Similarly, _2 capital Z lowercase z is not legal because there is no element with the abbreviation capital Z lowercase z. The second type of syntax rule pertains to the structure of a statement, that is, the way the tokens are arranged. The statement 3 equals plus $6 is structurally illegal because you can't place a plus sign immediately after an equal sign. Similarly, molecular formulas have to have subscripts after the element name, not before. When you read a sentence in English or a statement in a formal language, you have to figure out what the structure of the sentence is. Although in a natural language you do this subconsciously. This process is called parsing. For example, when you hear the sentence, "the other shoe fell," you understand that the other shoe is the subject and fell is the verb. Once you have parsed a sentence, you can figure out what it means, or the semantics of the sentence. Assuming that you know what a shoe is and what it means to fall, you will understand the general implication of this sentence. Although formal and natural languages have many features in common, tokens, structure, syntax, and semantics, there are many differences. Ambiguity. Natural languages are full of ambiguity, which people deal with by using contextual clues and other information. Formal languages are designed to be nearly or completely unambiguous, which means that any statement has exactly one meaning regardless of context. Redundancy. In order to make up for ambiguity and reduce misunderstandings, natural languages employ lots of redundancy. As a result, they are often verbose. Formal languages are less redundant and more concise. Literalness. Natural languages are full of idiom and metaphor. If someone says, "the other shoe fell," there is probably no shoe and nothing falling. Formal languages mean exactly what they say. People who grow up speaking a natural language which is everyone, often have a hard time adjusting to formal languages. In some ways, the difference between formal and natural language is like the difference between poetry and prose, but more so. Poetry. Words are used for their sounds as for their meaning, as well as for their meaning, and the whole poem together creates an effect or emotional response. Ambiguity is not only common, but deliberate. Prose. The literal meaning of words is more important, and the structure contributes more meaning. Prose is more amenable to analysis than poetry, but still often ambiguous. Programs. The meaning of a computer program is unambiguous and literal, and can be understood entirely by analysis of the tokens and structure. Here are some suggestions for reading programs and other formal languages. First, remember that formal languages are much more dense than natural languages, so it takes longer to read them. Also, the structure is very important, so it is usually not a good idea to read from top to bottom, left to right. Instead, learn to parse the program in your head, identifying the tokens and interpreting the structure. Finally, the details matter. Little things like spelling errors and bad punctuation, which you can get away with in natural languages, can make a big difference in a formal language. Section 1.9, the first program. Traditionally, the first program written in a new language is called Hello World, because all it does is display the words Hello World. In Python, it looks like this: print hello world in quotes. This is an example of a print statement, which doesn't actually print anything on paper. It displays a value on the screen. In this case, the result is the words hello world. The quotation marks in the program mark the beginning and end of the value. They don't appear in the result. Some people judge the quality of a programming language by the simplicity of the Hello World program. By this standard, Python does about as well as any language ever has. Section 1.10, the glossary. Algorithm, a general process for solving a category of problems. Bug, an error in a program. Bytecode, an intermediate language between source code and object code. Many modern languages first compile source code into bytecode and then interpret the bytecode with a program called a virtual machine. Compile, to translate a program written in a high-level language into a low-level language all at once in preparation for later execution. Debugging, the process of finding and removing any of the three kinds of programming errors. Exception, another name for a runtime error. Executable, another name for object code that is ready to be executed. Formal language, any one of the languages that people have designed for specific purposes, such as representing mathematical ideas or computer programs. All programming languages are formal languages. High-level language, a programming language like Python that is designed to be easy for humans to read and write. Interpret, to execute a program in a high-level language by translating it one line at a time. Low-level language, a programming language that is designed to be easy for a computer to execute, also called machine language or assembly language. Natural language, any one of the languages that people speak that evolved naturally. Object code, the output of the compiler after it translates the program. Parse, to examine a program and analyze the syntactic structure. Portability, a property of a program that can run on more than one kind of computer. Print statement, an instruction that causes the Python interpreter to display a value on the screen. Problem solving, the process of formulating a problem, finding a solution, and expressing the solution. Program, a sequence of instructions that specifies to a computer actions and computations to be performed. Python shell, an interactive user interface to the Python interpreter. The user of a Python shell types commands at the prompt, 3 angle brackets, and presses the return key to send these commands immediately to the interpreter for processing. Runtime error, an error that does not occur until the program has started to execute, but that prevents the program from continuing. Script, a program stored in a file, usually one that will be interpreted. Semantic error, an error in a program that makes it do something other than what the programmer intended. Semantics, the meaning of a program. Source code, a program in a high-level language before being compiled. Syntax, the structure of a program. Syntax error, an error in a program that makes it impossible to parse and therefore impossible to interpret. Token, one of the basic elements of the syntactic structure of a program, analogous to a word in a natural language.